This is problem 28.4 from homework 6, and we're given this figure here of circuit with a 9-volt battery on this side, an 18-volt battery on that side, and a resistor with a resistance of 30 ohms up top. And for part A, they want us to calculate the magnitude of the current in the 30 ohm resistor. So using Ohm's law, which we know is the potential difference equals the current times the resistance, we can just rearrange that in order to find the current. And we know that to find our potential difference, we just need to sum all of the potential differences that we run into around the loop. So notice that the positive side, this is the positive side and this is the negative side of the battery, so the electrons are going to flow towards the positive side. And then also on this side, the positive side's on top and negative's on bottom, so the electrons are also going to flow up on this side. So when we're calculating some of our potential differences, we need to take our 9-volt and we need to subtract that 18-volt. And then so we get our potential difference equal to negative 9 volts. And then if we plug that in to our equation, we take our 30 ohm resistance and we get the magnitude of our current as 0.30 amps. And for part B, they want us to calculate the direction of the current in the 30 ohm resistor. And our current is going to be going right to left. And we know this because if we were to calculate the individual currents of each of those from each of those potential differences, we would get move that down. Okay, so we would get, for that first one, we would get a current of 0.3 amps from this battery, and then we would get a current of 0.6 amps from this one. So the current would be stronger coming from this side, which is why it's going to flow right to left rather than left to right. And yeah, that all ties into what we're learning in chapter 27 with resistance and capacitance and Ohm's law.